seriously interested in CNC routing and considering purchasing one of these, I'm going to let you know what you're in, and we'll get into this. I spent all day yesterday machining this lovely lady's head or girl's head, 3D in aluminium, and I consider that to be a failure in actual fact. I'm going to answer quite a few of your questions over the years about owning and operating one of these CNC machines, what to look for in one of these machines, and how to service it and upkeep it, and just a general look around it and general information about the tooling that these machines operate. And the first question that I'm going to answer is one I actually received this morning, and that is, how loud are these machines in operation? I can tell you from experience of using these machines, a CNC router, whether it be a 6040 or bigger, the amount of noise that it creates depends largely on the size of tool and what you are machining. So say for example you have a piece of MDF which everybody machines. In these machines, if you are using a small type tool like a 3mm ball mill, I'll just get one. This is a 3mm ball mill, okay, or roughly 1/8 of an inch. If you see it's rounded on the top. This is for doing 3D carving of a fairly small nature. Now I think everybody understands what dB is, or decibels. Now running this little tool in MDF at 50 millimeters a second and roughly about 20,000 RPM, you can expect 65 decibels or dB, which is about as loud as what you hear me now. That's about 65 decibels, conversation sound level. Now the other end of the scale, same material, MDF, but running at 50 millimeters a second speed, RPM for this tool. Now this is a 2-inch or 51 millimeter. This is for machining something flat or removing a lot of material very quickly. You can expect anything up to and possibly above 110 decibels, dB. As a rule, the smaller the tool, the lower the noise level. So, you know, be advised. That's that question out of the way. Before we go any further into this video, these are my personal preferences of what I would be looking for in a CNC router, and my personal views on how to operate a CNC router and the tooling that can be used in such a machine. So this is a 6012 CNC router. This is not a typical machine. This is quite a high-end, high specification machine. It's constructed with a solid welded steel chassis, and this black area that you see here, I'll fetch you in a bit closer. Okay, so I'm going to show you one of the things that makes this a high-end machine. This black area that you see that goes up all the way underneath here, and this whole thickness is 1 inch thick, and it goes back for about 3.5 inches, and this is about 1/2 inch thick. This is cast iron. It's not welded box section or aluminium, extruded aluminium. This is cast iron. running on square linear rails. So in other words, the gantry, which in itself is one cast aluminium unit, the gantry is held very securely to the bed. So in other words, the gantry doesn't flex, doesn't move. The majority of machines out there don't have anything like this at all. So you have the steel framework which holds the main cast iron backbone, and on top of that, this is a stainless steel tank or bed. It's fully welded and waterproof, because you can actually machine stone on these as well. The next layer then is this aluminium T-slot bed, and on top of that is this rubbery or plastic bed. Just now you heard me talk about linear square rails. Now that's the bearing rails that all the axes run on. There's also linear square rails for the X and linear square rail for the Z. This machine is also equipped with hybrid servo motor drives. When operating your machine, you should always keep this area clean from dust and debris. Always keep the door closed. Never run the machine with this door open. You know, electronics can be a bit touchy, especially if they get dusty. Okay, so they are supplied with grease nipples, but I actually never use grease in them. I mean, they're packed with grease from the factory, I understand, but what I do is use light engine oil and just put a little dab, little pump, only a little bit on the top of the rail, and when the machine is operating, it sort of tends to wipe the rail with, you know, spread it on the rail, and that's all it needs, because you need to constantly, you know, sort of wipe the dust and debris off the rails if it gets on there. Okay, so now we come to the spindle, which is really, I suppose, the heart of these machines. Now, my preference is water-cooled and 2.2 kilowatt, which is 3 horsepower. The reason for this is A, you get extra grunt, and B, the size of shank of tool that you can put in here. Let me just grab one. So the size of shank that you can, the shank is the shaft part of the tool that you put into the chuck or the collet. You can put anything from 1/8 of an inch up to 1/2 inch shank fits in that tool, which means you can use large tools like this. That's another reason why you want something like 2.2 kilowatt for the torque, the extra torque. When they advertise these machines, they advertise it with 800 watts or, you know, up to 1.5 kilowatt. Unfortunately, those size rotor heads or spindles take a maximum shank size of 6mm or 1/4 of an inch. So don't get caught with that one. If you go for 2.2, invariably you can get up to a 1/2 inch shank of tool in them, plus you get the extra torque. I would probably guide you away from air-cooled. You know, water-cooled or coolant-cooled, should we say, is much more reliable. It stays really cool, and you know, because these can get, or would get, really hot, because, you know, they run for hours at a time. at, you know, speeds up to this, in this particular case, of 24,000 RPM. And you know, these are a high speed operating machine. So if you think you're going to be drilling with drills, it's probably not the best machine for doing that. Because I find, especially drilling things like aluminium, it sets up how the minimum RPM that you can run these is about 5,000 RPM. And if you've ever drilled a hole at high speed, you'll know that it vibrates and shakes around, makes a hell of a mess of the hole, as these do. Now, what you can do if you must drill a hole with a CNC router is use a smaller end mill than the hole that you want to drill. Just say, for example, it's an 8mm hole or a 10mm hole. What's that, 3/8 of an inch? Well, you use 1/4 of an inch or a 6mm end mill, 2 flute, and you. Now the action is called interpolation, and that is you sort of cut the hole in a spiral, and it feeds it down, it cuts it in like this. And not only that, you want to peck drill as well. Now you will learn by looking at some of my videos how to set this up in the CAM strategy, okay, or the CAM machining strategy. It all gets a little sounds complicated, but really what that means is now the machine strategy for drilling a hole would be to interpolate, which means spiral, and retract or peck drilling, which means you go in a millimetre or 2 or 1/16 of an inch, and you draw it back out to clear the hole, and then you go back in, do a bit more, bring it back out, in, and all the way through. Now different materials require different amounts of being able to drill in and retract. You'll discover a lot of that for yourself. Now there's another thing too. A lot of people buy a CNC router or CNC machine and expect to go straight in and produce beautiful 3D carvings like this one, for example. The chances of you being able to, as a novice, to be able to purchase one of these machines, get it home, and go straight into one of the CAM programs and produce this is so minimal it's near non-existent. You need to start off just by moving the machine around with Mach 3. Now that's another thing too. Don't be bamboozled into getting any sort of program other than Mach 3 or Mach 4. If they try and push a machine on you with some other unheard of programming that the machine works, walk away very quickly. Mach 3 or Mach 4. Linux is okay as well. I don't use it myself, but Linux is okay as well. But certainly Mach 3 or Mach 4. USB conductivity. None of this 25-pin port, because if you use a 25-pin port, that means you're working with an XP or at best a Vista. That's 12 to 15 years old. You can't buy computers, not new ones anyway. Very difficult to. So they're outdated. So the 25-pin port ones, forget. USB conductivity only, I would suggest. So you're getting a lot of information in a very short space of time really here. Okay, so we've covered linear square rails, we've covered the best type of motors to have is servo motors, definitely cast iron backbone, 2.2 kilowatt spindle, linear square rails to all axes. Oh, something I find very handy too, and that is the tool set-in. Very useful device where you put this on top of the material like so, and you know, and a pendant. I always use a pendant these days. Push a button on your pendant, this comes down slowly, registers the height of the, you know, how far the tool is off the top of the material. Very handy. It's probably about a $20 extra or less. You might get it for nothing. Stipulate it that you have it machine with that on. Now then, power. Now I know in America a lot of the power wall plugs there are 110 volt. I would suggest that if you can in your region, I'm sure you can, have a 240 volt power supply put into your garage or your shed, wherever you're going to use this machine. Most of Europe is already 240 volt. It doesn't cost any extra, but you know, I regard it as much more reliable, I suppose, and it's what I've always been used to, so I always sort of say, well, go 240 volt. Okay, coolant. Now I think about 2 or 3 videos back, if you go and have a look at that one, I had the water pump, coolant pump, pack up on this. Now what they tend to use, look, basically all these machines come from China, and what they supply is a pond or aquarium pump, which is fine for the job. My experience, and if you go back and have a look at that video, is that they last about 3 years, depending on, I suppose, how many hours you use it per year, but about 3 years and they're about done. So my advice would be about every 2 years change the pump. Now the coolant now depends where you live. If you live in Canada, North America, most of Europe, you get snow and ice and frost. Probably not a good idea just to run plain water. I use an ordinary vehicle antifreeze in my machine, and it works quite well. I mean, we're in southern Tasmania, we get snow, ice and frost here during the winter. So this machine, definitely, living where I live, antifreeze, and I would suggest to you to do the same. This video has come about because over the last 4 or 5 years I've probably get about 50 messages per day asking me to advise who to buy a machine from. So what I'm trying to do is give you the information of what to look for in a pretty decent machine. And of course this is what I would look for in a machine. And all these items add up to, well, quite an expensive machine. Now you will, if you go on to eBay or Alibaba or somewhere like that, you will see these, this is a 6012 by the way, so it's 4 foot by 2 foot operational area, but in millimeters it's 600 by 1200 operational area. You will see these for around about $4,500 US. Now then, you won't get the items that I have spoke about earlier in this video. That's all extra. Of course, this is set up for 4th axis work too. Now, just say for example you have all the extras that I have: 4th axis, servo drive, 2.2 kilowatts, cast iron, all the extras that this machine has. This is the top spec machine. Coolant, table. You're probably looking at around about $8,000 US. Then they say, oh, free shipping. Well, of course the shipping's built into that cost. No one sends you a machine weighing 300 kilos or more halfway around the blooming world free. It just doesn't happen. So there you are. There's a lot of information in this video that I've shared with you of my preference, what I would order with a machine. If you order anything less, well, there's the old saying, you get exactly what you pay for. So if you think you're going to order a machine off eBay and to be able to do what I do, well, I don't think you are. So just be prepared that what you see, what I do with my machine, it is not with a $3,000 machine. So just keep that in mind, because you're only going to be disappointed when you start using a lesser version and it turns out not to be quite what you think it's going to be. And you know, a lot of the machines out there, sorry to say, that you could well be throwing your money away. What this machine will cut or machine? Well, the list is very long actually. You know, MDF, hardwood, softwood, any wood material, even bamboo, I have machined on this. When it comes to metals now, things like brass, copper. Copper's a difficult one to machine actually, but it'll do it. Aluminium. 3D cutting in aluminium, it's a bit iffy, because what you tend to happen is it just needs a small amount to weld itself to the end of the tip of the tool, and it drags through the material and ruins everything. Yeah, so it's very difficult to keep a constant cut going, as indeed the next video will show that. Brass, bronze, any of the ferrous metals. Now these machines, even though this one is built really strong and stiff, I wouldn't advise trying to machine steel or cast iron or anything like that. Even titanium is a bit iffy, because titanium, when you're machining it, it work hardens. The initial cut, you know, it'll cut okay, but then when if you're doing something like a 3D machining in titanium, it'll just get harder and harder and harder and harder, and in the end it'll probably bust the tip of the tool off. I've never machined it on my machine, but the science behind it, I suppose it should be able to machine it, but one day I'll try some. Damascus steel or any of the exotic metals like that, you need a dedicated CNC mill for that. A Tormac, or my little Sieg mill that I converted, that'll do it. That'll do it just fine. But CNC router, no. So the envelope that these things will actually machine is quite large. So the opportunity for manufacturing is quite wide, as you can produce things like this. If you look through many of my videos, you'll see that I produced a lot of 3D machining, but it'll also do 2.5D as well, like the little Land Rover there. It'll do 2.5D cutting. So the work envelope for these machines is quite large. Physical size of this. All my machines in my workshop actually on wheels, so this is about 6 inches higher than what the machine actually is. So it's brought this machine up to a comfortable height for me, plus it's easy to move around the workshop if I want to. They don't tend to move around a lot, but the wheels do have lock-in mechanisms on them. When it comes to programs, like I've already suggested, if you order a machine, order it with either Mach 3 or Mach 4, and the same goes for your CAM program. Now, Fusion 360 is free for hobbyists and businesses up to, I think it's $100,000 turnover per year. So you have good CAM abilities in that program. If you're thinking of actually making a 3D item like this, it's not a simple process. I do actually show you the different processes through my video selection of how to actually make something like this. It's very complex. You have to something like this isn't made on a computer as in someone draws it, and that is very, very difficult. Something like this is 3D scanned, and then it's put through something like ArtCAM or Carveco or Aspire. So you get this. So it's not an easy process to make a 3D object, although you actually can if you've got the time and build the experience. Again, you can buy 3D files off the internet from a reputable company. I'd be very careful, because buying a file off the internet can be dicey. Operational speed and feeds. Now that is a very complex thing as well. Each material has its own, I suppose, speed and feed with its sweet spot then. In this particular case, this was a mixture. Basically, 90% of the machining was hardwood, but then it came into the softwood. Not really too much difference, but what I find with this particular material, this is oak and pine, the happy medium is 80 millimeters per second of speed. There's 80 millimeters per second feed. Now that again is broken up into, it doesn't mean to say that the tool is going to run 80 millimeters or what's that, 3.25 inches, 3.5 inches per second. That is broken up into, see all these contours. Okay, so you get in a straight line, it'll do 80 millimeters or 3.5 inches per second. but then it slows up and comes up and down, up and down, up and down, follows the contour of whatever the program is showing, or over the body. And of course, the less that the z-axis moves, the faster in X you can move, if that has any sense. So you've got to break it up into X and Y. All right, so it has to slow up for the Z to jump, and then jump back down or whatever, So that's broken up, and the electronics inside the machine determine, and the motors themselves determine how fast you can actually cut a 3D object. So and that's something you're going to find out for yourself. So as a rough guide, I can tell you this particular machine, 80 millimeters a second feed, speed, RPM of the motor. When you're using like a 2 millimeter something like this. Now this is a tapered ball mill. It's got a 1 millimeter radius ball, which is about a 1/16 of an inch, just under that actually, at the end to do a 3D carving like this. This is spinning at maximum RPM, which is 24,000 RPM. So, and of course, the larger diameter of the tool, the slower your RPM needs to be. Like I think I did the roughing with this with a 12 millimeter. I did the roughing with a 12 millimeter. That one. This is a 3 flute. 2 flute would do it as well. End mill. And this was running at, I believe, if my memory serves me right, 14,000 RPM. And again, 80 millimeters a second in feed rate. And the speed and feeds of different tools cutting into different materials, you build up the knowledge of this by using the tools and using the machine and busting the tools or welding material to the tools if you're in aluminium. Obviously metal, the feed rate is about 25% of whatever you're doing through wood, or even less. But you will learn that. But like I say, don't go running away with the idea that you're going to purchase one of these machines, sort of off eBay for $2,500 or so. Get it home and then immediately machine something like this, because I'm afraid to tell you that's just not going to happen. So if you're interested in a CNC machine, do your homework first. Start talking to some of the companies, and if they cannot provide you anything near what I've suggested, run away very quickly. And again, what looks to be a cheap or reasonably priced hobby that you can do at home, you're going to learn very quickly that for anything decent, it's not cheap. So I hope my personal views on the subject has been a help to you, and if you'd like to come and see the next video where I'm machining in aluminium this young lady's head, I'd be really happy. Of course, I'm not really happy with this. It's okay, but it just, when you're magnified into it, when I videoed this fills the screen, and it looks absolutely terrible. But it's not too bad when you have it out like this, and see it sort of in its real sort of life, it looks okay only. Next time when I do something like this, I'm going to do it in brass. You know, when you machine it in brass, it's a much better effect. But of course, it's about 5 or 6 times the cost for a lump of brass this size. Actually, maybe 10 times the cost of aluminium. Extremely expensive, but I think I might have a go with it in brass or bronze or something like that. So, okay. So I hope you've liked the video today, and I hope it's been of assistance to you. And please like and subscribe. Also, at this stage, I would like to put a big shout out there and a thank you to my patrons, because it's the patrons behind this channel that allows it to exist as it does today. So thank you very much, guys. Thanks again for watching, and I suppose it's bye for now.